I'll get it uploaded today. I can't do it till Monday because I cannot do it over the weekend. It's wide. There we go. All right, so 12.5 grams. Grams to moles, not mil. All right, moles on the bottom and atoms on top. What goes beside moles? Ones. Beside grams? 121.76. All right, and beside atoms? Avogadro's number. The man's not a vegetable or fruit. It's not avocado. I think he's a fruit, or avocado's a fruit, but I can't swear to that. Probably some kind of vegetable.
Hey, how you doing, sir?
How you doing, Miss Wall?
I'm doing fine. I hope you are. All right, I got 6.18 times 10 to the 22nd. Everybody get something like that? Okay. Now, it doesn't have to be exactly my answer, as long as you have 3 significant digits and you're in that ballpark. Okay? Everybody okay with that answer? Somewhere in that range. All right. So we look at number. Oh, you need me to wait? Okay. Okay. All right. So number 2. How many moles are there in 1.56 times 10 to the 25th? Atoms. All right. Atoms. Moles. What goes beside moles? And beside atoms? Avogadro's number times 10 to the 23rd. So when we punch that in, 1.56 second EE 25 divide 6.022 second EE 23. I got 25.9. And that's moles. Are we okay with those? All right. Question 3. I said tell bond type. How do we decide if it's ionic? Metal and non-metal. And covalent? Both who? Both who? Non-metals. I thought that's what Samaria said. All right. So when we look here at MnNO3, what's Mn? It's manganese. But is it a metal or a non-metal? It's a metal. As soon as you can say that's a metal, you automatically know it's what kind. It's ionic. As soon as it has a metal, it's an ionic compound. All right, CaI2? It's ionic. That's a metal again. And PCl3? Covalent. All right? And I asked you to write the formula in number 4. So Al has what? Oxidation number?
3.
And N, nitride, has a 3 also. It has several oxidation numbers written there that we talked about yesterday. And the rule is if it's last, it has to have what oxidation number? A negative. And that's why we narrowed it to a -3. Did everybody remember that? Okay. Now, when you crisscross, you would get Al3N3. What do we do to those 2 3s? Cancel them out. Did everybody do that? I picked this one specifically because I know that everything we did yesterday, we didn't have anything that reduced yesterday, and that's a failure on my part because everything we had, it just didn't reduce. So when you look at these, you can either recognize it here or here. You remember step 4 yesterday? All the compounds that we had were like this one, CaI. You had a 2 and a 1, so you had a 2 that came down and a 1 that came down. Can you reduce a 1 and a 2? No, they're already in lowest terms. So you wind up with a formula of CaI2. Or we wound up with something like Na3P1. We can't reduce a 3 and a 1, right? It's in lowest terms. But this one has a 3 and a 3. What happens in math class if you have 3 over 3? It equals 1. Same thing happens in science class. If you can reduce both of these subscripts by the same number, you have to reduce. So 3 and 3 can both be reduced by what? They can reduce by what?
3.
3. So we're going to reduce them by 3. So this 3 and this 3 are going to be reduced by 3, which is going to leave us ALN. The easiest way to do it is when you see these up here at the top, they are going to do what to each other? They're going to cancel each other out, and you get ALN. Questions? And you'll see more of that as we cruise through the next few days. It doesn't happen very often, but it does happen on occasion. Same thing happens if you had something like, let's say you had carbon 4 oxide. All right, carbon would have a 4 and oxygen would have a 2. What's going to happen when you have a 4 and a 2? They're going to reduce. So you wind up with a 2 and a 4, and that 2 and that 4 are going to reduce to what? A 1 and a 2. So you wind up with CO2 as a final answer. That happens sometimes also. Okay? And you'll see more of that as we go through the next couple days. Questions about anything in the opening? All right. We're not doing homework next. You'll see I put quiz next because naming and what we were just talking about is not part of the quiz. So there's no need for us to focus on that first today because that is not on the quiz. Now, I need openings before I forget. Sometimes I do forget to take them up, even though it's day 10 and I told you I was going to take them up. So, on my desk is a stapler. Please, for the love of God, put your name on the top sheet. Every time I take up openings, I usually get 1 or 2. If somebody does not write an opening name off, okay? I do not know your handwriting well enough to figure it out. If it's only 1, I can usually use the process of elimination. But work with me. Put your name on your paper. Stop writing. Stop writing.
Literally, I have him right here and he'll steal it from me. Snatcher or crumb snatcher.
You're a crumb. You're a crumb.
Leave me alone.
Are
you supposed to leave me? Yeah. I spelled my name wrong the first time I wrote it.
Dang.
That is sad. Jamie, see under the drum. People be trying.
I thought it was sad. I saw it.
People be trying.
It's okay, Miss Ron. I'm gonna have one more just like that in this class.
Trying.
I hope that doesn't, bode poorly for quiz today.
It's not.
You're
Okay.
We the
I'm
people.
expecting a whole bunch of 90s to 100s. I want a whole bunch of 100s, but I'm fearful of significant digits and units.
This is bull.
People get careless and forget things.
Hey, Jay. Jay, you can't just take my words.
Shut up, man. What?
Jay, look,
You some bap. You some bap.
what?
You some bap.
Oh, no.
You just ugly. That's all you do. He's a bap.
Hey, you an ugly crumb.
And apparently he had no longer because he's still in khakis.
What's wrong?
This match.
Mama ain't wash her clothes yesterday.
It's just match.
You don't wash your own clothes.
I do.
I don't wash my own clothes. Sometimes. I mean, my mama don't do it too. Why not?
All right, do I have them all? All right, you need your periodic table. If you would like your blue reference table, since it has Avogadro's number on it, get it out. If you're one of those who are confident, I know Avogadro's number and I don't need it, you do not need your blue reference tables. But if you want that, by all means, get it out. Okay? But I told you can always have your chart. You don't have a table? Oh, well, you should feel cheap. Is there anybody else like in Florida who was not here today? I gave out periodic tables and does not have one. So everybody else has a periodic table. So if you lose it, I can get back. All right. Let me grab the quiz. All right. Show your work. You have to show work. No work, no credit. Why they for response? I didn't want work, I give you multiple choice. No work, no credit. Show your charts. Don't forget your significant digits or units. I like hundreds, not 97s and 98s. Okay, I get a lot of those because people get careless. Put your significant digits and units on it, so I got all hundreds.
Old versions.
So. Sorry about that. Probably not. I'm good at that, so. No matter what it was. I'm not so sure. Oh, yes, it is. No, Jessica and I. We will be. Switch. So he got stuff. This one last time, he was one. Or football. So, heard it out loud. So then he switched ways and wound up there. Right. Right. I was like, yeah, I want you to. He said that. Nope. First time. Oh, you're right there. Oh, you're talking that. Oh, yeah. So as long as you do the best thing and you take, yeah, that's so much. I'm not doing that today. I can see. Well, you could say me back then. I think it's yeah, you're still not. Because I just went. Yes, good. And I put that tweet for the only two.
Well, I just put in general comments, and then it just sort of overflowed into this one.
Yeah, I did it.
I do like the straight height. Yeah, no, so. That's it. So, it's
Yes.
That's all.
Maybe I'll put that in and never do I'm just like, down there.
She said she could do it to her. I'm sure she can.
Maybe I'll fill that with that.
Fill it with spinach.
I think that was, and what's it for the box? I'll take it again.
Yeah, I helped me.
Yeah. Maybe I'll put that. Non-destructive. Participate. Okay, maybe I'll do that, but hey.
I didn't have anything there. I had to process. I couldn't do it on the fly.
But, yeah, I'll think about what you just read, write that down. Why not?
So you only had 9, right? Openings.
No, I think I should have been on that.
Only got 9 of them dated. Green. Show me where the 10th one is, since I can't find it, or I can't count it. Jade, I only had 8 on yours, is that right?
Yeah, I think I missed 2 days.
Okay. Okay, so that's the one you did. Okay, there's the, you put the date in the wrong place. So you can change the format on me and confuse me. All right, thank you. if you're still working, this will have an idea. Got it. I have people who are still working at this point. little bit more. Voilà. He's still working. Anybody? Your hands down. All right, pass scrubs to the front. All right, Stephanie, grab those one. So I just screwed up. All right, find your homework. Something again. Thing that I didn't do. working on this stuff. All right, I will try to get those graded today so they're in Power School, but no guarantees. All right, let's find our homework and talk about writing the names, because we didn't have a lot of time to talk about being able to figure out if you do or don't need a Roman numeral. So I'm expecting that we might have had a little trouble with that today. So let's see how we did. Let me get a blank copy. Anybody absent yesterday needs a copy of the homework? Is everybody here? Everybody was here? Okay. All right. So in number 9, you should have copper, Roman numeral 2, chloride. Number 10, magnesium bromide. If you don't have IDE on the end or you have a Roman numeral, it's wrong. Number 11, calcium oxide. IDE on the end, no Roman numeral. Number 12, iron, Roman numeral 3, oxide. Number 13, manganese, Roman numeral 7, oxide. Number 14, silver, fluoride, no Roman numeral. Number 15, potassium iodide, no Roman numeral. Number 16, aluminum nitride, no Roman numeral. 17, tin 2, Roman numeral 2, chloride. Number 18, barium sulfide. And number 19, lead, Roman numeral 2, iodide. Yes, ma'am.
Okay, so how come on all the other ones they have Roman numerals, but on number 10 there's no Roman numerals?
Okay, it depends on when you look at the sheet. All right. So when you look at a compound like Fe2O3, all right, and you name iron, look up iron on the blue card. How many numbers are written beside the iron out here? 2. It has 2 numbers. Okay? Because there are 2 numbers on the sheet, you need a Roman number. Okay? Doesn't matter what the numbers are. But the fact that there are 2 numbers listed on the sheet tells you you need a Roman number. Okay? Now don't look at the sheet to figure out what the Roman numeral is. Now you look at the formula. So put the sheet down. Look at this formula. This 2 came from oxygen. It's negative because it's last. This 3 came from iron because it's first. So it's positive 3. So the Roman numeral that goes with the iron is Roman numeral 3 because the iron has the 3 that came from it in the formula. And then you can write oxide behind it. Okay? Now, the one that you asked about was which one? 10. Okay? So when we look up magnesium, what do they have behind it? Cl2, Br2. All right? On the sheet, magnesium has how many numbers written over here? It says +2. Okay? There's only 1 number. That tells us there is no Roman number needed. Because every time magnesium's in a formula, the only number it can ever have is a what? +2. Okay? So we're just going to write magnesium and bromide. Okay? So you're looking to see how many numbers are listed on the sheet. Okay? That's the important piece. So when you looked up iron, it had how many? It needed a Roman numeral. Magnesium had how many? 1. It does not get a Roman numeral. So you got your blue sheet handy? All right, let's just start at the top. All right, the first element is aluminum. How many numbers does aluminum have written beside it? Will aluminum get a Roman numeral? No. Okay, the next element is antimony. When you look at antimony, how many numbers are listed beside antimony? Will it need a Roman numeral?
Yes.
Yes. Okay, because it has more than 1. The only time it doesn't get a Roman numeral is when there's how many numbers listed beside it? 1. How many numbers are listed beside aluminum, Jay?
Oh, I was looking at manganese. Okay.
Yeah, you're looking at manganese.
My bad.
Okay, magnesium has 1. Manganese has multiple. That one's going to need a Roman numeral.
Yeah,
This one is not. Okay, so like aluminum has how many? Antimony has, it's going to need a Roman numeral. Okay, so if we keep going, arsenic's going to need a what? Is arsenic going to need a Roman numeral?
Yeah.
Yes. What about barium?
No.
What about bismuth?
No.
No. Okay, so if you only have 1 oxidation number, you don't include a Roman numeral. So somebody yesterday said on the way out the door, they were like, can we just put in a Roman numeral to cover ourselves? The answer is no. If you put in a Roman numeral and it doesn't need to be there, it's what? It's wrong. Okay, we don't just add it in just to cover ourselves. Okay, so let's try 5 more and make sure we've got it before we go on to polyatomic ions. All right, do those 5. Write their names. And then we're going to move on to polyatomic ions.
So how many ever like oxidation numbers that are?
All right, however many oxidation numbers are on the sheet doesn't tell you anything. It just tells you you need an oxidation number. So when you look at this, antimony, you look up here. So did you decide, yes, I need a Roman numeral? All right, what number in this formula came from the antimony?
Oh,
Okay, once the sheet says to you, okay, I need a Roman number, you use the formula to figure out the Roman number. You with me, Stephanie? You with me? Okay. Who else has a question? Anybody?
So what is there's the 2 numbers, you don't put the second number right here.
No.
The first one.
No, you. So what are you saying when you say
So like, we don't, it's the 5, we don't-
right? Because the 5 came from here when you crisscross. That's when you put it up there. Okay. Anybody else have a question? Anybody?
okay.
Uh-huh.
So it says chlorine
Chlorine is irrelevant. Doesn't matter what chlorine has.
Is
You're
that
only,
-1?
doesn't matter. You're only interested in that first element. So you look up that one, and it has how many? So it does not need one. This needs what kind of ending? Yes. So every time you forget that, I'm gonna mark it wrong regardless of the Roman numerals. Everything except this. All right, which number came from the antimony? Don't drop straight down. And do what? Like crisscross. All right.
All right.
What number came from the antimony?
All right.
Yes. The number came from up there, from antimony. Remember. So what number did you write?
Five. Like, oh, you're supposed to put.
No. It doesn't matter what number's on the sheet. What number's in that formula? Yes, now it's right. Guys, the blue sheet is only to tell you if you need a Roman number. You use the number that's in the formula. Okay? The Roman number might not even be on the blue sheet. Okay? Like I might have a number in the formula that's not actually written on the blue sheet. Yeah. Yes.
So we don't even have.
No. The only problem I have looking at yours at a quick glance is that is not RB. RB is not RB. It is that. That means what I'm ending on. Anybody else? Question? Who said you, Justice, right you?
So, for this one,
Mm-hmm.
I think,
It doesn't matter about chloride. Chloride's irrelevant, he's last.
oh, yeah.
Okay, you're only interested in rubidium. Mm-hmm. So what now? No, it's gotta go right after the first element. It can't go last. There are a couple polyatomic ions that have Roman numerals at the end, but it's part of the name, and we won't use those at all. Okay? Yeah. Mhm. Yes.
Yes, sir.
Not that. You need one, but you have the wrong number. What number came from the
Oh, it's
chromium?
3.
Yes. All right, so if we look at what y'all came up with, all right, does antimony need a Roman number? As soon as you look at this sheet and you go, oh, antimony has more than one number, put it down. Don't look at it again. Only look at what's here. All right, antimony, oxide, and then what number in this formula came from the antimony? The 5, and that's the Roman numeral you want. It doesn't matter what that sheet says. Okay, let's say for just a minute that I had a formula that said Sb2O7. Look at your sheet. Does antimony have a 7 on the sheet? Does antimony have a +7 on the sheet? No. Half of you, if I put that, will come up to me during the quiz or the test and go and swallow. There's no 7 on the sheet. I know. Okay? So what are you supposed to write right there if there's no 7 on the sheet? The 7. Okay?
The formula has a 7 right here, so you would write a 7 right there if that's what the formula has, okay? The blue sheet is to tell you that it needs a what? A Roman numeral. So you put the oxidation number or the Roman numeral that matches your formula. In this case, it was a 5. In this case, it's a what? It's a 7, okay? But your Roman numeral has to match the formula, regardless of what is on the blue piece of paper, okay? The blue piece of paper is to say, oh, I need a Roman numeral. I don't need a Roman numeral, okay? What RBCL tell you? Roman numeral or no? No. So you wrote rubidium and chloride. All right, number 3. What'd you find out? No Roman numeral. So strontium and then bromide. And what'd you find out on number 4? Yes, so you wrote chromium and then you had oxide and you said, what Roman numeral would I use? That 3. That 3 is what came from chromium. So you wrote 3 right there. And then the last one, yes or no? No. So you wrote barium and sulfide. Questions about how to write the names? Anybody? You feel better about when we do and don't use the Roman numeral? Okay. Now, today, we're going to talk about ionic compounds with polyatomic ions. So, your homework sheet from last night, don't lose it. The practice that goes with today is on the back side of it. Remember, I was conserving paper. Now, the same steps that we learned yesterday are the same steps we're going to use today. We're going to begin by writing formulas. Okay, we're going to write formulas first, just like we did yesterday. Now, the only thing that's different is we have to add in one tiny little step. So let's say that we want to write the formula for iron 3 sulfate. Can anybody tell me what's different about this name versus what we were writing yesterday? The ATE. Okay? That's the biggest thing you should notice about this name. Okay? This right here tells us that we have a polyatomic ion. Right there. That's what it says to you. It's a polyatomic ion. Now, if you were in some chemistry classes, you'd have to memorize those. Okay? My daughter's chemistry teacher has given them 25. They have to have memorized by week 4. Be thankful you're not there. Okay? Not a big fan of memorization. Mainly because I've gotten old and I can't remember my name. So, let me tell you how I arranged this sheet. Some days I wasn't very bright. Wasn't the most tech-savvy person on the planet. So, in my infinite wisdom, I decided to try to make columns. So, let me use white sheet paper, probably work better. On this side of the chart, you figured out last night that you had an element, a symbol, and some oxidation numbers, right? Had no trouble with that. Well, Miss Wall was trying to conserve space. Thought I was brilliant back in the day. Okay? So on this side, I put the polyatomic ions and their symbols. They're largely alphabetized. But then I realized, oh crap, I left out some polyatomic ions. And then I was like,
I already attached those places. I can go back and insert those without jacking up the other side. Oh, I can't sort that without messing up the other side. So they're down at the bottom. So they're almost alphabetized with some that are not quite alphabetized. So if you look, most of them are alphabetized. There's a few at the bottom of them. So when you need your polyatomic ions, for example, sulfate, if you cruise down the list to the S's, you will find sulfate. Okay? So we need to write its formula. We have iron. Iron is an element, so we find it still on the left side like you did last night. So iron symbol is what? Fe. What's its oxidation number? Now why are you people all looking at that blue sheet? Where do we find the oxidation number? How'd you know that? Very good. Okay. When we look at this thing, this little Roman numeral right here says that that is the oxidation number. We don't need to be looking at the sheet. So iron is a +3, correct? All right, sulfate. Now, we need to look at the sheet. Y'all don't know sulfate. Now, those of you with really good memories, after we do this for a while, y'all, oh yeah, sulfate says so far. Blah, 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 blah. Some of y'all gonna have to look it up every time. So, sulfate has what formula? Look it up so you know how to find it. It's SO4 with a what? With a -2. That -2 is the oxidation number. Okay? Just like we did on the other side, a little -2 is the oxidation number. Now, here's the only new piece. Put parentheses around the polyatomic ion before you crisscross. Okay? If you put parentheses around the polyatomic ion before you crisscross, you will not mess up any of the numbers. So, it's SO4. The 4 is part of the polyatomic ion. It's part of the formula. I can't touch the 4. It's sacred. So I'm leaving it in the parentheses. The only numbers I'm moving are the 3 and the 2. Okay? So, this 3 is going all the way across the parentheses over here. This 2 is going all the way across the parentheses over here. Okay? So, when I write this formula, all I have to do is rewrite it exactly as what we just did. This is Fe, and it has what subscript? It has a 2, parentheses, SO4, close the parentheses with a 3. Does that make sense? The only thing that's different is the polyatomic ion. Process is the same. Ready to try another one?
Yeah.
Okay. They're not hard. After we do a couple of them, you'll be like, okay, it's not hard. All right, so let's say that we have sodium phosphate. All right, what's sodium? I heard it out there. Na. What's its oxidation number? Huh? It's +1. All right, what's phosphate? It's who? Ends in ATE, so it's not a single element.
PO4 with -3. Now, anytime we have a polyatomic ion, we need to put what around it? Parentheses. All right. We're crisscrossing the 1 and the 3. So the 1's coming over here. The 3 is going over there. So all I'm doing is crisscrossing just like yesterday. The only difference is I'm just going all the way across the polyatomic ion. Okay? No, that's what I'm getting ready to talk about. That's why I picked this example. So when I rewrite my answer, Na3, PO4. Now, I'm not writing the 1. Now, because the 1 does not have to be written, do I have to include my parentheses here? No. Now, I'm pointing this out because of the next example I'm going to show, and it causes huge, huge issues. Okay? The parentheses are optional because the number outside is a 1. Okay? Most textbooks won't even show the parentheses. They write it as Na3PO4. They leave them out altogether because the number outside is a what? 1. I will still write the parentheses most of the time for y'all. I don't care if you write the parentheses. I will not take off. Okay? But the parentheses can be left off because what number is outside? A 1. Now, to illustrate the difference, does everybody have what they want? Okay. Let's say that we write antimony 5-hydroxide. All right. Antimony is what? I heard it. SB. It has what oxidation number? All right. Hydroxide. Find that on your chart and don't yell it out because lots of people write the wrong ion on this one. Find hydroxide. Don't yell it out. Give everybody a chance to look. All right, you got it? All right, what is hydroxide? It's OH with a -1. A lot of times people will tell me it's H with a -1, and it's not. It's OH. Hydroxide is OH with a -1. All right, so given that, what do I do? Parentheses, okay? Now, I'm going to explain the difference in just a second. We're going to do it right, and then I'll talk about what people do wrong. So we get a 5 over here and a 1 here. And we should get SbOH5. Are the parentheses optional? No. Okay? Why are the parentheses not optional? Okay? They're not optional because the number outside is not a 1. So, every year we do this, people say SB with a 5, OH with a 1, and they go 1, 5, SB, OH, 5. And every year I mark it completely wrong. The reason is after we do naming, we're going to use these same formulas to do math. Okay? And you have to add up the number of items. What do parentheses mean in math class? And what other function? Multiply and what? Say it, Xavier. Distribute. So this 5 is going to multiply and distribute to the H and the O. So how many H's are there? And how many O's are there? So when we calculate, we're going to have 5 oxygens and 5 hydrogens for the purpose of finding their mass. How many O's are here? There's only 1. There's 1 O and there's 5 H's. So if you leave off the parentheses because you don't put them in, you're going to calculate the mass wrong. So that is wrong, which is why I take off for it when we do naming. It's not right when we calculate. Okay? The only time the parentheses can be left off is when this number outside is a what? I heard it. When it's a 1. Okay? Everybody understand that? You got your homework from last night? On the back side, I want you to do as many as you can in the top section before I stop you. Some of you will finish the top section. Some of you will not. Okay? It's on the back. The top one says silver nitrate. Okay? Do as many of them as you can. Yes. Okay. Since I'm sitting here grading quiz papers for a moment, and I just took off 3 points on someone's paper who's probably going to get seriously bent out of shape when I give their paper back. A is not an abbreviation for atoms. That stands for angstroms in chemistry class, not atoms. M stands for what? Meters, not moles. You got it. If you want to abbreviate moles, it's MOL. Okay, so.
Wait,
Uh-huh.
if you like write it in the chart, but not as the answer, like you put the full thing as your answer, but what about?
What do you mean?
Right.
Like when you wrote the answer, you didn't put moles on it, or you
No,
wrote,
like when I wrote the answer, I wrote the full thing, but in the chart, I put like G for gram, like A for atoms.
it's fine in the chart as long as the answer has a full unit.
Okay.
What's it put, MO instead of MOL?
-1.
I have a question.
Uh-huh.
Is sulfur the same
Is sulfur the same as what?
sulfur?
Sulfurous? No. You don't know the sulfurous acid? Just look it up on your sheet under acids.
How we coming? We done? Any more time? Where we at? They knew the answers and it's come out. You did it charts, but you didn't put on any answers. The worst you did is you have AT for an atom for an answer. Not bad. 95 was the lowest grade we had.
For what?
95.
You're passing
Huh?
it. You're passing it.
Good God, I ain't passing the computer yet. I'm not that fast.
Okay, what's live or ocean?
Yeah.
When you're doing the calculations,
Mhm.
those, do you suggest that we do like divide, you suggest we multiply,
It is.
and then divide, or do it all?
It's up to you.
I'll put it-
You could multiply first and then divide, or you can divide and then multiply. I multiply and then divide. That's just because that's the way I always did it in high school, so I still do it that way. But it doesn't matter. If you're more comfortable dividing the two first and then multiplying, you can do it that way. It won't matter with your order of operations. All right, let's look at what you came up with for those that you did. If you haven't quite finished, it's okay. All right, let's just check what you got. If you've done, has everyone done at least 5? Everybody got at least 5? All right, so let me find a worksheet again. All right, so on the back side, AgNO3. If you have the parentheses, they should be around the NO3. Number 2, Na2SO4. If you have the parentheses, they should be around the SO4. You don't have to have them because the number outside of both of those parentheses are a what? A 1. So they're optional. You can leave them off. Number 3, they are not optional. They must be there. Fe, parentheses, ClO2, close the parentheses, 3. Number 4, Pb, parentheses, ClO4, close the parentheses, 4. 5, Zn3, parentheses, PO4, close the parentheses, 2. 6 is H2SO3. That's just an acid you look up on your chart. You don't do anything with that. 7, NaClO3. The parentheses can be around the ClO3 because the number outside is a 1. They're optional. 8, Al2, parentheses, SO4, parentheses, 3. That's on the wrong one. Trying to mix the two questions. And 9, Mg, parentheses, NO2, close the parentheses, 2. Questions? Any of them you want me to talk about or do? 6 is H2SO3. If you look on the back side of your chart where it says acids, one of them says sulfurous acid. You just look that up right now. No, sulfuric acid is H2SO4. This one says sulfurous. Okay. Any of them? Number 8 is Al2, parentheses, SO4, close the parentheses, 3. You mean to do that one?
Yeah.
Okay. Aluminum has an oxidation number of 2. Sorry, 3. Al has a 3. Sulfate is SO4. It has a -2. You know the negative we don't care about. Put the parentheses here. Bring your 2 down and bring your 3 down. So you have Al with a 2, parentheses SO4 with a 3.
Also, we put the oxidation number. So we put the oxidation number.
Yes. 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 Tiffany, what's wrong? You sure?
Yeah, I got it.
Okay. Anybody else question on any of those we did? Yes? No? Okay. So, writing names. All right, this is the last piece we're going to do before I let you cut a whole bunch of pieces of paper up on Monday and glue them down in practice. All right. Now, yesterday, the 3 steps that we wrote down. Number 1, we said we're going to write the first name. Step 2, we were going to write the second name and add an IDE ending, right? And then we were going to check the oxidation number. The only step we're changing is step 2, okay? For polyatomic ions, there is no IDE ending. Okay? You look up all the elements together after the first one. Okay? So when I say look up all the elements together, I'm talking about after that first element. That first element, you remember, is in that step 1. You're writing his name. Sodium, nickel, magnesium, manganese. Whatever that first element is, you're just writing its name. So after you've written that name, look up all the elements together on the blue sheet for one name. You don't have to figure out its name. You don't have to add an ending. You don't have to do anything except write it down. Okay? That's the beauty of the blue sheet. So, if we have something like this, how do you know that this one is not going to get an IDE ending? The what, Tomas? That's right. Okay? This one should scream at you, no IDE. Okay? This right here says this is a polyatomic ion. So there is no IDE ending. Remember, you only add IDE if it's binary. What's binary mean again from yesterday? 2. Does that have 2 elements in it? I see several people shaking their heads no. How do you know? That's exactly right. Count the capitals. How many capital letters do I have here? I have 3. I have an A, I have a C, and I have an O. That's 3 capital letters. It's not binary. It's not getting an IDE. That's one way. You could have taken Tomas' shortcut. It's got parentheses, Miss Wall. It's got a polyatomic ion. Okay? That one ought to slap you. Okay? Everybody with us on that? Now, the easy way to name this is it's got parentheses. We're just looking up the name. So, what did we do last night for homework? What's the first thing we did to write its name? Look up the first element. So what's the first element's name? So we're writing aluminum down. Now, last night we'd have done what for the second part? Okay, so we don't have to do that today. We're not looking up the second element and adding IDE. Today, we're looking up this name. So, look up all the elements together on the blue sheet for one name. So, you're looking up all of this together for one name. So, you're hunting on this polyatomic ion side together, looking for ClO4 for one name. So all you have to do is write down perchlorate. Now, that substitute out number 2. Now we've done step 1 and step 2. Now we need step 3. So what was step 3 last night? The Roman numeral. What do we have to do for the Roman numeral? Check the first element. Go ahead, Jade. If more than one oxidation number, we must use a Roman numeral. All right. So what can y'all tell me about aluminum? It has 1 oxidation number. So if it has 1 oxidation number, does it need a Roman numeral? No, it's done. Aluminum perchlorate. Okay? So, suppose we have this. And we want to write its name. Ni, 2, and then parentheses, C2O4, close the parentheses, 3. All right, what is Ni? Nickel. All right, what do we know about C2O4? And do we need a Roman numeral?
Yes.
Okay, so if we need a Roman number, what Roman number came from nickel?
2.
I hear 2, I hear 3. All right, my 3 people getting mad. All right, how do we decide? That's right. Did this 2 come straight down? No. They have to be reversed. 3 came from here, and 2 came from here. Okay? So that's why the 3 people were getting a little vocal back there. You have to reverse your crisscross. Okay? Questions? All right. Now, let's talk about one that always causes issues on the test. Let me pick a good one. Let's do that one. Suppose I put that one on there.
All right, what's CU? Copper. All right, SCN. What do we do with that mess? Okay. Now, I said in these directions to look them up together, right? Now, don't do this on the test. I get it every year. Sulfur, carbon, nitride, or some weird something. Half the time they don't even put the right ending on it. Now, there are exactly how many names in a compound? 2. A first element and something behind it, whether it be an element with IDE or a polyatomic ion. If you find yourself trying to name every element in the compound, you have gone off the deep end and done something wrong. Okay? It doesn't work that way. This blue sheet is your salvation. Okay? Find SCN. What's his name? Cyanate. All right, Jaden might have some skills here. Got some phonetics going on and pronunciation here. Copper thiocyanate. Now, step 3. Do we need a Roman numeral? Yes, we do. Now, all right, I hear 1, I hear 2. Got some dissension in the crowd again. Why can't we all agree? All right. So, what number came from the copper? Okay. Now, we're going to talk about reducing next week. Sometimes it might be a 2 because it canceled out. What oxidation number did thiocyanate have? It had a -1. So, was there a 2 ever that could have canceled out somewhere? Copper was a 1 also. It is a Roman numeral 1. And I picked that because if it's ever a 1, people go, why do we have to write a 1? We don't write a 1 anywhere else. This is one of the times you do have to write a 1 because you have to tell me the oxidation number is a what? A 1. Remember, the Roman numeral's function is to say, use this Roman number. Use this oxidation number. If you don't tell me it's a 1, do I know it's a 1? No. Okay, so this is a case where you have to tell the 1. So copper 1 thiocyanate is the answer. Questions? All right, at the bottom of that sheet, I want you to do as many as you can.
Are we going to do one where it reduces?
Where it reduces? Yes, but I'm going to save those for next week. We're going to learn a whole lot with that. With like covalent compounds, about half of the covalent compounds reduce. And in order to name covalent compounds, you have to go back and figure out what it used to be before it was reduced. I know. That's why people like the old system with the prefixes, because you don't have to do any of that. But then people go to this and they start sticking in prefixes. Like next week, people are going to make that nickel trioxylate and screw up the name, which is wrong.
Mm-hmm. Nothing. You'll never have anything at the end. Now, check those and see if you need Roman numerals on all those. All right, zinc has how many oxidation numbers right here? The number of numerals. Aluminum has how many oxidation numbers right here? So what do you Roman numerals? No. 2, 7, 8. Okay, Julius. Now you've looked up the first element and everything and have no complete answers for us to our answers. How many oxidation numbers does zinc have? So see how you put that? Would it need a Roman numeral? That's right. What you write. Okay. Same thing for sodium. That is correct. So when you look up sodium, it is subtract side purple together. That's no Roman numeral. So you're not going to use Roman numerals because it only has one number. Got tons of questions. What numbers does zinc have? And put next there. Okay. All right, let's run through a couple answers and see how we're doing. All right, question number 10. Lead 4 nitrate. You gotta have the 4. Number 11. Zinc chlorate. No Roman numeral there. Number 12. Aluminum chromate. No Roman numeral. 13. Sodium phosphate. 14. Iron 3 sulfate. Number 15, calcium iodate. Anybody get further?
Yeah.
Okay. Nickel 3 carbonate. 17, potassium phosphite. 18, sodium perchlorate. Further?
Yeah.
Potassium permanganate. And 20, lithium hydroxide. All right, for homework tonight, I want you to do 1 through 20 on that paper I just handed you. All right, 1 through 20. Okay, everybody got it? 1 through 20. One through 20.